Hey, D-Daxter here with another great math video here for you. We're talking about the basic graphs of polynomial functions. All right, so we're dealing with functions, their graph, the number of turns, their end behavior, and their multiplicity. So we got a lot to cover here, hopefully in a short amount of time. So a lot of information on this board. We'll try and keep it straight. But I've got a lot of questions recently that people have come to me and said, hey, Dykstra, can you do a video that covers all this stuff in one fell swoop? So here we're going to go. So let's start over here with what the functions are. Okay, so we start with y equals some plus or minus x to some nth power. So, and we're just going to go through the basics of them, okay? All the way up through the power of 5. What the graph generally looks like, right? There's multiple exceptions, and there's shifts and things, and stretching and horizontal and vertical stretch. But, you know, this is just kind of generally what they look like, okay? And then we're going to take a look at how many turns they have, how you know it's a various polynomial, and power. And then we'll go from there and we talk about end behavior, which is what they're doing as x goes out to negative infinity or positive infinity, and what's the y values doing. Okay? So let's take a look. So let's start with positive x squared. Now hopefully we all recognize that that graph looks like a parabola. Okay? And as we come to the number of turns, we get one turn. Okay? And that just basically means that as the graph comes down, as the curve comes down, there's only one turn. There's no more than that. So, and this is what we call the turn right here. This is the turn. And it's where the graph turns around and goes the other direction. Okay, so that is our turn. And if we look at the end behavior of a quadratic or a positive x squared, as x goes to negative infinity, then the y values are going up, right? The y values are going to positive infinity. And as same thing, as x goes to positive infinity, the y value is doing the same. So the y values are both going up. All right? Now we look at its partner, and we say, when you have a negative x squared, both point down. Okay, both point down. So the sketch goes like this, from the frowny face, if you will. So one turn again, because there's one at the top. And then this time now, as x goes to negative infinity, the y values are going to negative infinity. As x goes to positive infinity, the y values are also going down, because that makes that upside down U shape. All right? And then we look at a cubic, okay? A cubic. So a cubic generally looks like this, where we start off from negative infinity and go into positive infinity in the y values. Now there's two turns. So again, we count each turn. There's one turn and there's two turns. Okay, so we get two turns out of it this time. And the end behavior, as x goes to negative infinity, as we're going this way, the y values are going to negative infinity. And on the other side of that is when we go to positive infinity for the x, the y's are also going to positive infinity. So they kind of match up there. If we make it a negative outside, if the leading coefficient is a negative value, then that just flips the graph. Now as we go out to negative infinity, the y values increase, and we still have two turns, 1, 2, okay? And then as the x's come to positive infinity, the y values go to negative infinity. Okay, so these are just generally what they look like again. The fourth is has three turns, right? So we got one turn, two turn, three turns. And as we go to negative infinity, the y's are going to positive infinity. And as the x's are going out to positive infinity, the y's are going to positive infinity. If we have a negative out front and it's to the fourth power, then you'll see it flips upside down and looks like an M, right? So as we go out to negative infinity, the y values drop, And as we go to positive infinity, the y values also drop right there on that side. Okay? And that's basically what's stated here. As x goes to negative infinity and positive infinity, they both go to negative infinity. All right. So now we go into the fifth, the root, or the fifth power. And if we have a positive, well, look, it's very similar to the cubic. Okay? So they start on the left side, and we come up, and then we go through 4 turns. 1, 2, 3, 4 turns. So hence we have 4 turns. And if we go out to negative infinity, then the y values decrease. As we go to positive infinity, the y values increase. And just the opposite of that, when we have a negative x to the fifth, as we go to negative infinity, the y values increase, and as we go to positive infinity, the y values decrease. Now you might be wondering, well, look, there's kind of a pattern to this, right? I mean, if it's squared, then it has they're either all going up or all going down. The same thing is true with the fourths, okay? So with the fourths, they're either both branches are going up or they're both going down. So they're either all up or they're all down. And if it's odd, then it's going to go, one's going to go up and one's going to go down. However they are, positive or negative. So you've always got middle transition in between, but one will go up and one go down. Odd or even, they're up or down, right? So it's a way to remember it when you do that. Okay, let's move along to what we call a concept called multiplicity. All right, so multiplicity is when we have these factors, after we've used synthetic division, we get some x to the cubed plus whatever in the polynomial function. We factor it out, and now we've got to try and graph it. So many times we'll teach people how to graph by the zeros or the x-intercepts. And so then it's interesting to see what the graph does if we have an odd power of the factor or an even power of the factor. So we look at the factor as an x plus a or an x minus a to the nth power. And then what is it doing? So if you notice, odd powers, right, n, 1, 3, and 5, they're going to cross the x-axis, okay? Now, I have a cubic represented here, but that doesn't necessarily mean that one of those turns doesn't bounce off. I'm just showing you, representing how it crosses through the x-axis. Even, however, powers 2, 4, and 6, when they're with a factor, they what we call bounce, okay? They bounce off of the x-axis. So you'll notice here that I've got just a parabola drawn, but it's bound. It came down, and then bounced off. So even powers bounce. So that'll be important to remember. All right, now let's look at what these multiplicity values actually are and what they mean. Okay, so multiplicity in a quadratic will have an x plus a or x minus a times x plus or minus b. And if there's nothing there, right, if there's no value there, then we assume they're ones. And when we assume they're ones, we know that both of these factors, that's why we call them the zeros, will go through the x-axis. They will cross through the x-axis. If, however, there's a square, then we know that that will bounce off the x-axis. Okay, it's just something to keep in mind. Try graphing x plus 2 quantity squared sometime and just see what it does if it crosses. When we get to cubics, many times we'll have all three factors written out, a, b, and c. Every once in a while, we will get an x plus a quantity squared and then an x plus a. Well, this one is a bounce, and this one is a goes through, right? It crosses. So this one bounces and this one crosses. So it might look something like this, where it goes through and then bounces off, right down here. So it could do something like that. When we get to the x to the fourth and x to the fifth, we can either have them all be separate, 1, 2, 3, 4, right? Because x times x times x times x would be x to the fourth. Or and those would all go through. Those would all go through the x-axis. However, if we get an x plus a that's squared, then and an x plus b and an x plus c, now we have two that cross, and we have one that bounces. So what that might look like is something where it's positive, so it comes up and it bounces off, and then it goes down and then comes like that, okay? Where both end up. But we have one bouncer and two that cross, and that's kind of what that looks like. All right. Well, that has been the basics of polynomial functions. Lots of information. You might want to rewind it, go back through it again. But these are some general polynomial graphs that we have to graph in class. And hopefully this gives you an idea of how that end behavior, what they look like, and how many turns they have to help you identify what type of graph you're going to draw. All right. Thanks again. Hope you have a great day, and peace out. Thanks again. D Dijkstra out.